All right. All right, everyone. Well, welcome, and thank you for joining us today as we're trying out a new format here for these tech talks that we've been doing this fall, and that we're not only live streaming, but we're live on campus. The recording is also going to be made available here. Hopefully there isn't too much background noise here. TJ, if it gets distracting, you let me know, and I'll go track down the noisemakers and get rid of them. I don't have my normal slides to go through. Just going to go ahead and introduce TJ and give him the entire hour here to go through his talk. TJ is an investigations team lead at Fish Tech Group, where he runs a team that performs security research and responds to incidents within client networks. Prior to Fish Tech Group, he worked, and I'm not pronouncing that. Arbor Acer, okay. He worked as a malware research analyst for Arbor Acer team, where his duties included analyzing emerging threats to internet security, reverse engineering malicious code, and communications protocols, developing policies for attack mitigation, and contributing to the continual improvement and automation of Arbor's internal threat analysis software infrastructure. He organizes his local security B-sides, which they had just last weekend, and leads a local information security group. In addition to numerous industry certifications, TJ holds his BS from Rochester Institute of Technology and an MS from Boston University, and is currently pursuing his PhD here at Dakota State. TJ, thank you very much for making the long trip to from South Carolina, not just to talk, but for the conference, and then also being willing to come up here and talk with us live.
So awesome, thank you so much.
It's all yours.
So I think everyone can hear me here. So I'll get right into it. So this presentation has a lot of slides that have screenshots. The goal of this presentation is sort of to give you an overview of the different techniques that can be used to hunt malware and the actors behind them. So without further ado, I'm just going to jump right in it. But before that, there are going to be 2 prizes. So after the talk, the first 2 people that ask questions are going to get a free book. So that will be your incentive to work throughout the whole hour, and just bear with me. All right, so to introduce myself really quickly, my name is TJ Nelson. I usually go by TJ Nell, and I am a DSU doctoral program student here. My Twitter is up there if you ever want to follow me, and my primary interests are malware and reverse engineering. I do work in that field, and I run teams that do forensics investigations and malware research for customers throughout the United States. So to kick into our presentation, I wanted to talk about why we want to hunt for malware and the actors behind them, and some of the primary motivations for doing this type of work, and why people actually get paid to do this type of work outside of law enforcement and other entities that are able to do this. So the primary reason is because we want to have threat intelligence research. People want to know who hacked them so that they can build threat models behind how to protect their organizations, environments, networks after the fact, right? So if you were hacked by a specific actor or a criminal group type, you want to be able to profile that, understand what their motivations are, their tools, tactics, and techniques that are used, so that you can block most of that activity prior to your next incident that may occur. So threat intelligence is a large portion of why people start doing these types of hunts. Block list generation is another one. So if you can identify different pieces of malware, especially new malware, imagine if you got the list of Emotet C2s before they hit your company. If you block that stuff, you're effectively disrupting the attacker's ability to operate in your environment before they can do stuff, right? So we want to make sure that we are blocking the threats that are coming tomorrow, today, so that tomorrow we don't have to worry about it. I don't have to get called at 3 o'clock in the morning because you guys got breached, right? The last one is for law enforcement action. There are often times where you will be able to find enough information where law enforcement can work towards putting down or capturing the entities that are doing those types of activities. And as we know, law enforcement is often overworked and they can't do everything. So private industry, commercial interests could come into play here, where if your organization was attacked by an actor, you guys were able to determine who that actor was, it's a lot easier to get justice incurred from that. So that can potentially stop them from hacking anyone further or continue operating in your environment. You know, it's hard to hack somebody from a prison cell, right? So that's the whole methodology behind that. So before we talk about some malware hunting, I just wanted to give you an idea of what malware is made of here. So traditional malware, and this is the most canonical example of the malware as an entity would be someone, a human being, is usually creating source code. That source code is then compiled into malware, so it's a program that's malware. This gets deployed to a victim's computer, so this is where the infection happens, and then typically that malware has to do something, or else it's worthless. Like I can drop a document into your computer, but if that document doesn't do anything, then what's the use, right? So the most iconic example is connecting to a command and control here. Now, throughout this whole life cycle, there are artifacts that are created. There are different things that you can monitor and identify that help you to identify the malware type and the actor, and that's throughout the whole process, every stage. So this talk, I really wanted to go through some of those things. Now, in the traditional hunting life cycle, we first start by looking for interesting samples. So these are like the emotets, the trick bots. Like these are the ones that the WannaCries. These are the samples that people talk about in the news. You want to try to identify these things. And to do that, you really want to just like do some searching, identify different functionality. And then you want to go into and start defining characteristics because we want to be able to put these different pieces of malware in a bucket, right? So like emotet and trickbot, they're similar. They're both banking Trojans. And they're used in similar ways, but they're different pieces of malware. And how do we define what's emotet and what's trickbot? Well, these are these characteristics that sort of help build a bucket around what this particular piece of malware is. Then we want to explore some similarities with other families. So because emotet and trickbot are both banking malware, do they become, like, did one of these families turn into the other? We could see this pretty often with like a banking Trojan called Zeus, where there was many variations where it adapted because these malware actors are always improving and evolving their techniques. So as you see, like they're going to be starting with one piece of source code, and then they realize that they're getting caught pretty often. So then they're like, all right, let's give it an upgrade. Let's change a couple things. And those things build lineage that you can follow. And so looking at the similarities between these families will help you define that lineage of that malware. Then you want to capture as many samples as possible. So once you have an understanding of what that malware is, I want to get as much information, as many different samples as possible, so that I have a good data set to come off of, because we're going to be able to pull and record indicators from that malware data set, right? So all the C2s, all the email addresses, all of the different types of files it's looking for. Because when you have that information, that's essentially going to be the stuff that you're going to be wanting to block in your environment, and that's where that block list generation comes into play. Now, I do need to note that this is not exact science, right? So there are many ways in which a malware actor can intentionally change or place information in these hunting results that throws off the researcher like myself. There's a lot of iconic examples where these are just files at the end of the day, and they can be changed, modified, and manipulated to send false flags. It takes a lot of reasoning and understanding on these different pieces of malware to really filter out the true indicators versus false flags. So when we are doing these malware hunts, there's a lot of different things that we are looking for. The first is going to be artifacts, and these can show up as characteristics of the malware file, metadata, signatures, different things that you could sort of name that malware from. This is how people know from a various file that this is emotet, and this is from a various file, this is Kronos malware, and these are how they sort of identify and put these names behind these different types of malware families. There's also similarities in behavior that we can look at. So like that's typically just the dynamic behavior of the malware and what it does. Oftentimes, these actors have a specific mission that they're trying to accomplish. So if we can identify and encapsulate that mission, that motivations, the MO of the malware actor, we can use that to bucket that type of activity as this is usually this malware, and we can determine that from the artifacts, but as well, the behavior is inconsistent with what this malware actor is trying to do. Now, there are many paths to take on this. There's many ways to reach success. There are going to be a bunch more techniques than what I'm going over. I wanted to sort of give you my greatest hits, the things that helped me do some of these types of analyses. So all of the tools, the tactics and procedures that I go over throughout this time, these are all things that you're going to have to Google and like sort of learn and be able to incorporate into your hunting abilities. And they're the ones that help me out, but there's so many more, right? And they're going to be developed over time, so there's multiple different tools and tactics that can be developed over time to further define and discover new pieces of malware in these actors. So the first one I wanted to talk about is fuzzy hashing. Now, there's a really good tool for this called SSDeep. And so what fuzzy hashing does, unlike how MD5s and SHA-1s work, where you can identify a piece of data with a fingerprint signature, fuzzy hashing looks for a like type binaries. So instead of just saying, okay, if this 10-byte file is unchanged, you go and you check it against the MD5 for another one, it's going to be the same exact one. If you change only as another the same MD5 hash, then you know that those two organizations or those two actors may be the same one because they have the same exact file. They're usually having the same exact data, so therefore the C2 that's inside that binary is probably shared, and either they have a strong relationship or an exact relationship between those. And this is a really good way to identify how prolific a certain actor is, especially if they have multiple different infrastructure endpoints that are delivering the same type of malware. You can also track target of where the sample is seen. So if you have multiple organizations that are reporting that they saw this certain MD5 hash, you can say that, oh, we're all getting attacked by the same person. And maybe you guys can share information and details. And they may be further along in the attack cycle where you can say what's happening to you currently? We need to block against that and sort of save your organization from there. So traditional hashing is really good. And usually the same samples mean the same actor, so that's really helpful there. But fuzzy hashing is where we're doing our hunting, and we're finding new samples, interesting samples here. So when you want to find new samples, you want to say, okay, what's the fuzzy hash of this emotet sample? Let's search across this, and then you can find all of the other different types of samples that you could be looking for in your environment that may be similar, but not exactly the same for those actors. You can also find new infrastructure, because when you change the C2 within the malware, that's going to change its traditional hash value, because it's changing data inside that binary. But if it has a strong match, and you're only changing a little bit, just the C2, you can find the same samples that just have a different C2 and enumerate a large list of C2 and other artifacts. And then also you can also match samples that may not be the same actor but are the same family. So if you have a certain family of malware like Lockybot, you can actually say, okay, I want to see all of the Lockybot samples, and this could be a bunch of different actors, but you want to just find how prevalent Lockybot is. So let's look at an example of this, and you could use a tool called VirusTotal, and that's an online portal, and they have a functionality in there from the top there that you can see similar samples based on SSDeep is what they use on the back end. And from this, you can take one sample and say, okay, this is this type of malware. Is there anything that's similar to this? And when you do that search in their portal, it will literally just list all of the things that are similar, and if you look down there, you can see the distance from each other. So you can see that there's a 12 distance in every single one of these samples. That might mean that there's configuration that's just different between those samples, but it's basically the same malware. And this is where I'm talking about the C2 may have changed, or different files that it's looking for may have changed, so that data inside the binary is different, but all the guts and the skeleton of it are all the same. So that's a really good tool that I like to use for hunting malware, and using those techniques and expanding on those techniques helps you find similar samples and gets a really good corpus of a different type of malware set. The next thing I want to go over is imports and exports. So in the PE header, you can include a list of imported or exported functions. These are just basically functions that are used by the program that are shared code that can introduce functionality. So something like, instead of having to hand program going up to a URL and downloading something, they just import download URL A or something along those lines. This is a statically linked in the header, but there's also other ways to do it at runtime or dynamically linking it. But for the most part, if you're seeing an unpacked piece of malware, you're going to see that their imported functions are going to really give an insight as to what functionality is going on with that malware type. So there is a good example here in PE Studio, which is a tool that can be used to look at binaries, PE binaries, and it highlights the different types of imports that are used for this tool. So in there, you can see the green section is all cryptography modules. Well, then you can sort of guess what that malware is doing. It's using cryptography for something, either encrypting its configuration files, or it could be ransomware. There's a lot of different things that you can pull from there. So this is really useful. And you can actually leverage this to do a couple interesting things. Because if you know that there's a certain amount of if you know there's certain functions that can be imported to do certain functionalities, if I wanted to find ransomware, and you know that the ransomware samples that you were looking at import all these functionalities, then all of the files that import those functionalities across the internet are the ones that you'd want to look at. Well, smart route malware researchers actually came up with a concept called imp hash, which is the imported function hash of a binary where it takes an MD5 of all of those import names. So the ones that we were just looking at in there, it will take them all in order and then make an MD5 hash of them. And so when you do that, you'll actually see that you can search for those imp hashes in a tool like VirusTotal, and then you'll be able to find samples that have the same exact breakdown of imported functions, which are commonly going to be similar samples, same variant, doing the same functionality, because import and export functions typically equate to functionality of malware. So understanding that and knowing that gives you the ability to actually go in and say, okay, I want to see all ransomware that uses this function, these functions in this order, and you'll be able to find that. Strings is another tool that I like to use, and this is actually one of the most prolific tools for being able to find information about malware. There's a lot of interesting stuff that you can find in the strings, the plain text of a binary file. You can see that there's insight that you can get, like malware functionality, maybe the intent of the malware actor. So if they're trying to work on certain things, you'll be able to see some of those stuff, like say if they're trying to look for Bitcoin wallets. Well, you're going to see mentions of different things that are associated with Bitcoin, like Ethereum and all that stuff inside of that malware binary if it's unpacked. You can also get some of the developer information. So if they put in metadata into the file, you can actually pull that stuff out pretty quickly. A lot of malware actors have been tracked on this because they get clever and bored, and they'll do stuff like call their company credit card shop or something along those lines, where it's like, really? But it happens, and we're going to use that to leverage how we can find their malware and dissociate things to them. And then you can also find attacker infrastructure. So you can actually find different things like the C2s that they're calling out to, even user agents that they're using. If you see FJUR anywhere, then you know that's not a common user agent. So you can actually search and find different other infections based off of that type of traffic. Now, to look at tools that use strings, there's pretty much two big tools that I like to use. Strings, just straight up, works very well. It gives you the plain text. It usually does four-digit ASCII numbers, 4 digits or higher ASCII letters, and it'll just print out those. Or Floss, which is actually an open source tool from FireEye that they actually automatically detect, extract, and decode obfuscated strings in PE files. So actually, if they're base64 encoded or they're stacked strings, it actually can go in and it'll get more information out than just regular using the plain text strings, which is super helpful. And if you look at the last screenshot there, you could see that Floss is in action there, and you can actually pull out some of that stuff. If you ran strings on that same binary, you're not going to see the user agent. You're not going to see a lot of the URL type artifacts. So one other thing that you can find in strings is the PDB path, and that's the program database file that's generated during the program compilation. This is actually a developer type tool, and basically what it's doing is it gives a reference to your program so that it knows where the debug symbols are. And this contains a ton of information. So sometimes in that file itself, it contains symbols, addresses, function names, resources. This is the coup de grace, actually exploit developers, once they have this file, especially for like things like Windows, this really helps them build out exploits because this gives the context around the program that they're trying to do analysis on. But the PDB path itself is just a string that shows where that stuff is located, where that folder and directory is located. And oftentimes, developers are developing on their own computer, which has a file structure. Most of us probably have C users, my first name, homework to do later, homework that's due now. I should probably be doing this right now, and then, file.pdb. So that's where a lot of that stuff comes into play. So we can get really nifty and track a lot of actors that way. And so I'll point to this example where APT33, an Iranian group, actually they have a pretty telling PDB path where you can track a lot of their software. And essentially, this group is actually a nation-state group. These are, these are the guys that attack other countries, and they get paid, and they're very, very persistent at doing so. So one thing we realized a couple years ago is that they always had the same groups doing the malware development, and they had the same exact infrastructure. So if you look there up at the top corner there, you'll see that C users xman_1365_x, and then you can see desktop homework, all that stuff. Well, there are some really smart guys at FireEye that started seeing this, and they were telling the community, like, hey, all of their malware has this PDB string. I'm thinking that this is like their actual desktop computers. Well, if you map it back, there's actually an institute that's in Iran that is contracted by the government. It's called the Mumbai Institute, and they actually are the developers of a lot of their malware. So it's state-sponsored malware that's university funded, and they're sort of leveraging those guys. And because one of their prolific developers just uses this type of methodology, like you could see that's their desktop, and that's how they're doing a lot of their work there. And we can track that stuff in things like VirusTotal because that information's available in the strings of their malware. So we know that it's APT33 when we look at file and we see that PDB path, because no one else is going to name their thing X. I mean, he must like Marvel, and X-Man is his thing, so that's something. Maybe that's his PIN number. He probably forgot about that, and then the X, I'm not sure. But that's understanding that customary indicator is really great. And if you open up any piece of malware, chances are you're going to see this. Most people do not strip this out, and this is just a functionality that happens from Visual Studio Code. It automatically puts it into your malware, into your document or your program in general. So anything that's compiled, it just does this because it wants you to be able to debug it later on. So this is a good mechanism, and we use this a lot. Here is this is the practical utilization of this. So if you are hunting for something like APT41, they typically use these type of keywords. And so I would look at that PDB string that we know, and I'd say, what is the most unique portion of it? So that would be the anti_win_mm. And so if we start searching for that in VirusTotal, you'll start seeing samples. All of those samples, those are the SHA-256 values of those samples, and there's a long list of them. All of those samples are different samples, but they have the same PDB string. What does that tell us? It's the same actor that's doing those type of stuff, or at least the same developer. And typically that means that's the same actor group, which means that same attribution. They were using the same TTPs, which means that if you know a playbook for APT41 and you've gotten to that point, you're going to be able to, say, okay, all right, first thing, we need to make sure we bin down lateral movement. Like, we need to make sure that we block RDP, or, these are the exploits that they're typically using, and you have a good go-ahead of just saying, okay, this is how we protect our environment from that standpoint. But this is a really great marker, and it's one of my favorite ways to track malware. A lot of malware researchers will use this, if available, if it's unique enough, to find malware before it really hits most companies. So the next technique is C2 communications. So many malware families use HTTP and HTTPS to communicate to their command and control. The main reason for this is because nobody's going to block the internet. Everyone needs to go to Facebook. Everyone needs to check their Gmail. They need to get their IG and all that stuff. So like, it's very important that internet works in most environments. And so therefore, malware is like, okay, well, we're not going to rock the boat. We're not going to do some obscure protocol that could be blocked. We're just going to do typical URL traffic. Well, there's a lot of things in URL traffic that you can use to track different pieces of malware. So some of those things are URL pages. So if you're going to a certain page, like, this is my badscript.php, like that's going to be something that you might, anytime you see that in your URL logs, you're probably going to want to look at. Also, URL parameters. So different things that are coming from your system as form input can be put in URL parameters, and you can track that to identify different pieces of malware. The last one is that some people, especially some malware actors, they get a little loose, fast and loose with their implementations of their operations, and they won't put like something simple as like an index file, and then they end up having open directories, and we'll talk about those things over the next couple minutes. So the first one is URL page. Now, URL pages, there's typically, when we have crime or malware actors, they are working with panels because their malware is going to be deployed into a computer, just like we saw on the earlier slide, and then it needs to connect to a command and control. Well, that command and control is a lot of work. It's like basically running a website, and it's not even just a website. It's a website that needs to communicate with a ton of computers, steal data, track all of them, be able to tell you if something's up and all that stuff. So like, they usually will have a panel. Which is basically like a website that manages all of the bots that are inside all of the infected computers that are inside their network. And so when the malware is executing on that system, it needs to check in with that panel to say, hey, I'm here. And then it probably gives it some information of saying like, this is where I live, this is what type of access I have, this is what the users of this system are, these are the credentials I could find, and it sends it all back to a command and control. Well, that command and control page that gets that information is usually called a gate. And actually, it's often named gate.php because malware actors don't care. They just want to steal the coffee maker and run out. Like, they don't really care about, a lot of the OPSEC unless they're heavy nation states. So one prolific and unique page that we find often is the FRE.php for LockyBot. So when you're looking for these things, you can actually find these, and you can see the different panels that are available for LockyBot just by knowing that that endpoint page is that naming convention. And so you could see on URL house, which is on the bottom, that it tags as LockyBot. Even the anonymous one, that's LockyBot. They just haven't tagged it. And then when you look at some of the traffic from the sandbox execution of it, it's connecting out to those guys too. So that's a really nifty way to sort of identify different pieces of malware, and you can do things like create signatures for them with a tool like Dakota, and whenever you see something in your network connecting out to anything.fre.php, be worried, it's stealing your content. You should probably be on that. So let's look in more in the URL pages. So a little bit more of this. So this is what a panel usually looks like from like a software standpoint. This is actually off of GitHub, so the LockyBot panel is open source, really, and you can set it up yourself and deploy your things that way. And a lot of criminal actors like that idea because free to make a lot of money. That's literally what their way is going through it, and that's why they actually keep a lot of that structure. So they don't really vary too much from the norm here, and they just basically use what's available to them. And I like the comment, "Don't be stupid. This is for educational purposes only." They will just use what's available to them. So if you were able to get behind any of those URLs, if there was an open directory, this is what you would see. You'd see the FRE file, which is what the malware connects to, and then I wonder what that random string with adm1na.php is. That's probably an admin page because it's admin and elite speak, so that's probably what you're going to be looking for. And you might want to, later on, we'll talk about some of that stuff there too, but you know basically the infrastructure of their panel, so you can use those as markers to track that type of malware. So LockyBot panel has FRE.php, so if we see FRE.php in our traffic, then guess what? You got LockyBot. It's not any more difficult than that. Let's talk about URL parameters. So URL parameters usually get passed to the C2 to track different things like identity and whatnot. This is a example of a card unloader panel callback phone home. And you can see that gate.php, that's pretty common there. But we can also marker on the different things that it sends back, because typically this is an automated thing. The malware infects the computer, then it collects different pieces of information. In this case, it collects all that stuff on the side here, and then it sends it back. So we can see OS, and then all that redacted stuff is just personal sandbox information that no one wants to have on the internet, right? And then the parameters or specific order can be used as a signature to say, anytime I see these type of parameters getting sent through traffic in this order, most likely is going to be card unloader or a variant of that. So it's easy to track that from there. One really fun one is open directories. So when the malware actor does not put an entry page, like index.htm, HTML, on their web page for their C2, that makes it an open directory. So it's basically like when you go to that page, it shows the directory or like a file system of that www directory, and it can contain a lot of stuff. So this can contain files, images, logs, things that are not intended to be publicly available, and you couldn't just go like badguy.com cx.php. You'd have to get it from an open directory, because that's the only way that you could sort of call that stuff or know what was behind there. So those are called open directories. They usually look like index of, and there's a lot of Google Dorks that you can find a bunch of these things, and you'll find that a lot of people have messed up in this way. And then this is what like one of those panels would look like. So I wonder what dumps.txt has in there. Like that's interesting pieces of information, and you could probably take that and look at that and say, okay, these are the targets of that personal actor. So let's look at this in an example here. So this is a canonical example of a open directory for a C2. Now, none of this really looks interesting. I mean, the config looks interesting. The admin is just going to be the admin panel. I would really probably look at the config, probably robots.txt. There's a temp directory that's pretty interesting. Oh, look, there's a zip file in the temp directory. And then when you go and open up that zip file, oh, look, Bitcoin wallets. Someone has had a good day, and they were able to steal a fair amount of Bitcoin wallets. So like you can actually find these things and track them back to the actor. One interesting thing about this too is that you can even go even further if you're really interested into the threat research, and there's tools like Bitcoin trackers and whatnot where you can identify where the transactions happen. So it'd be interesting to take all of those Bitcoin addresses and see if there's money that was pushed away from them, because those are all victims and their Bitcoin wallet information. So if there's money pushed away from them, they're all going to the same or multiple locations, you can start mapping out the actors' infrastructure and their money schemes and whatnot. And that's happened many a times with large security research groups, and they were able to take down and recover a lot of operations based off of stuff like that. Another thing you can find is, oh, let's look at that config.php and see what's in there. Well, oftentimes you'll find things like passwords. You'll find things like databases and things like that. So in here's an example of the SQL information for a malware actor. Now, this is gray area, right? Because in open directories, if you download something from open directory, you're not intruding on the environment. But if you do use these credentials to log into a SQL database, then you might be, you're very well into the gray area. But that information's there, and the user and the password and the database name and all that stuff, if you put that in there and look at it, most likely you're going to see the information from all of the victims. So you can get some victimology. This helps out a lot of law enforcement, and that's how they actually get a lot of like, oh, this is how much damage happened, and they quantify it. I'm sure cyber insurance is frothing at the mouth right now saying, oh, nice, we can, we can evaluate things. The next thing I'd like to talk about is code structure. So this is more getting into the RE of things. So code usually follows a branching structure. So you make decisions, you act on those decisions, and it sort of moves from here. So I'm not going to go into reverse engineering. You guys probably have many courses that I go off of that. I know I have in this in my time here, but it's really just visually understanding the flow of a program. This is the Olympic destroyer. This was the one that happened when a certain country got really mad about being excluded from the Olympics, and they decided that they were going to want to retaliate. And so if you look at this, you can sort of see what the branching and the code looks like. And a lot of times malware researchers and stuff like that, they look at this stuff to sort of get an idea. If you see, one block and then it spreads out to like 10 blocks and you see lines going to it, what's that going to look like? It looks like a menu, and that's probably what it is. So it's taking a decision or a command that was sent in there, and it's doing different actions based on that command. Do I want to download something? Do I want to execute something? Do I want to just burn down this computer? Like, there's a lot of different options that come there. So when you look at this, you can sort of see the linear nature of this, and you can get an idea of like what that malware is, what the visual look of that malware is. Now, when you're really lucky and you look at a lot of pieces of malware, you can find similarities between those. So if you look at Olympic Destroyer and then you look at Perpy, which is another piece of malware that's older than that, you look at them and you're like, oh, wow, those guys are pretty similar. They look almost the same, right? And so one would be able to make that assumption that, oh, they're variants of each other, or one was in the same lineage as the other. And that's really great, because sometimes you can, positively attribute Perpy with the new actor, or vice versa. So when you see things like this, and here's another example with the Brave Prince and then the Beavis, which look basically identical. You can actually see same static values across the board there. You can say that, okay, well, either this snippet of code is exactly the same, so they borrowed from each other, or they're from the same variant or family. Because if they're two different pieces of malware and they have these similarities in these key areas, then chances are they're either borrowing from each other, or they've done different things to sort of just make sure that to give them an assumption that they are the same, or they're from there's some sort of cooperation that was in play here. There's many ways to do this. So you can look at code similarities using like a diffing tool. I like Diaphora. It's an advanced programming diffing tool that's a plugin in IDA. There's other ones too, like there's Radar, Diff, and there's a lot of different things. And essentially what it does is it takes two binaries and compares them and sees how similar they are. It's like the SSDeep of the reverse engineering world, where you look at the binary disassembly and sort of see how close they are. And a lot of times they will give you visual results. So this is Diaphora running in IDA, and you can see that the two pieces of code where there's similarity and how they look the same. And then also it'll give you a rundown function by function of how similar they are. So the green is very similar, and then the red is where they start differing. And then you could drill down and actually look at the code and see what's different. And oftentimes you can actually see that between versions of different malware, you can identify what's new there without having to look at the whole thing, because you're looking at what the differences are. So when they add new functionality, that's going to show up as red. Or if they do different things like changing the C2 address, that's an easy way to find what's different there. And also like different stuff like if they took out something because they never used it. A big one of that is like some malware used to use Tor, and now they're like, well, that's the FBI has control of that, so let's not do that anymore. And so they rip that out of their code base to make their software smaller. So some of the techniques that you would want to use here would be comparing the different versions of the same malware to see if there's new functionality. Like I said, you can find keys, like I said there. And then also determining if one variant is actually similar to the other. You can also find lineage. So the next nugget of knowledge is JA3 hashes. JA3 hashes are a way to fingerprint SSL client applications. So if you have a certain application, like Meterpreter, for instance, running on Linux, and it makes an SSL communication, the JA3 hash of that is actually the same. So you can profile actors based on that type of information, because you will know that if someone coming from this address using this type of software in this manner is pretty much the same person. And this really helps with you doing profiling on different types of malware activity or actor activity. You can actually, if the malware connects immediately, like if malware actually connects out to the C2 directly, you can actually use this to actually JA3 hash that malware and identify the usage of that malware across network traffic. And the way that that works is that you're looking at the PCAPs there and the SSL communication, and you can pull it out. And there's many tools that do it. Mostly IDSs do that stuff, and it's a really interesting tool to look into and understand. This is actually pretty new stuff. It was just open sourced by, I think, Salesforce, if I'm correct or not. But it's a really interesting research opportunity for people if you wanted to look into that. So let's get into the good stuff, hunting the actor. So typically, if you want to hunt the actor, the methodology that I typically use is if I discover malware, something that's interesting, what I'll want to do is I want to see if I can identify different distribution and infrastructure around that malware to get an idea of where it is, where it's prevalent. And then I look for IDing the actor, and that's when you get a random handle of Super Overlord 33 or something like that, and then you're like, all right, well, I don't know who that is, but that's a cool name. And then you try to do some escalate. So you try to identify more information about them, and then you can end up escalating this stuff. One of the really good resources for this is going to be the dark web and underground markets. So malware operators usually have to sell or distribute their malware to make profit. And so they have different things like the advertisement for a carton loader that we talked earlier. That's that actual advertisement that they were using to sell their malware. So if there was any, if there was any question on if he was doing it for educational purposes or not, that's it, $50 and you can get this. And so this is typically how you'd be like, okay, well, this is a criminal actor because they're actually trying to profit from their work of building this malware. And usually either the actor or they sell to a distributor and this distributor's selling, and they have to place ads on these marketplaces and forums. And there's information that could be used to find those people. So oftentimes you'll see email addresses and things like that that you can find, pivot off of and find some of their information from there. So you can use this information to trace them back to different things where they're using either their handle, they're using their email addresses, Jabber accounts, anything along those lines, and you can actually find more information about them and sort of lead towards what they were doing. So in this case, carton loader, he has this nice, cool logo. I mean, that ad, top tier, they definitely spent some marketing budget there. And they have this nice, cool logo. Well, guess what? Someone on GitHub has the same logo, and they use the same handle. I wonder what that is, and look at the stuff that they have. All right, collection of cracked malware ebooks, dirty cow exploit, like all these different things. Oh, and then absent loader, all this code out here. I wonder if he's ever interested in making malware and distributing it. I don't know. So then you go through here, and then in fact, this case, and I'm not going to tell you who this is because they're out of this country, and the FBI already knows about them, and they're technically a security researcher now, so they've gone the right path, I guess. And so you can actually find different things. And the thing about GitHub is that you have your user account, but then you also have email addresses. There's other information that you can put in your profile. So if you eventually pivot off this profile, you can find out exactly who this is, which we have. And then you can, I'll talk about how you go about escalating from there. But yes, you'll see their stuff on code repositories because they're going to be Googling everything just like you guys do when you have to finish the assignment really quickly. Social media, everyone wants to be on IG, so sometimes you'll see them flexing their stuff on IG, like, oh, I just made $50,000 selling malware. Here's my Lambo type stuff, and you can catch them on those things. BEC actors are really famous for that. If you ever look at any of those indictments, you could see their Facebook accounts where they're just all the new cars that they get and all that stuff, and that's how a lot of times they get caught is all the connections that they make. And then forums like Stack Overflow. Malware actors use that stuff just like we do. How do I hook this type of process without anybody knowing about this? I wonder what you're doing, man. It's pretty obvious. So you can start catching some of those guys based off of that information. Another way is infrastructure overlap. So we're looking at the artifacts that are in their tooling. So domains and IPs, code syntax markers, those type of stuff. And I'll sort of speed up here because I know I'm long-winded and I only have 50 more slides, so bear with me. So domains and IPs. So some of the big ones is going to be like the whois details. So you're going to get email addresses, phone numbers, and all that stuff. There are the privacy things that are going out right now, but for the most part, like older data, you can actually still catch those. Those guys have been online for 10 years, right? And we didn't have privacy protection all those years. So if you have historical whois data and you saw an email that they've been using for 10 years, you might be able to see some old domains that they've had. And guess what? Their names, their addresses, all that information may be 10 years old, but I don't buy a new house every 5 years, so that might be a good way to find people, right? Hosted domains with same IP address, so you can actually go through and look at those. And then IP addresses, reverse IP lookups work out really well. And I'm going to go through some of these examples. So finding IP addresses, I'm finding various IPs from IP lookup or domain lookups is going to be a big one here. So that's all infrastructure that was on that domain. That's a malvertising domain, and they move their infrastructure a lot because those IPs are getting blocked because that's where people are seeing the traffic on their firewalls and their IDSs. So that's why they're blocking those things. But you can see the lineage of that, and you can start tracking that stuff, and you can even put moderators into tools like RiskIQ so that when there's a new IP for that type of attack, you can proactively block it. IPs to domains, so you can check an IP, and if you see activity with an IP, you can see all the domains that are associated with it. I wonder what this guy was doing. Chase bill payments. Okay. Apple support.tk, like those are type things. Like this guy's trying to convince people to give him information, and they're using him in phishing and fraud type stuff. So like it's a really great way to find information on different types of actors. Now this one's been in the public recently. Sometimes the code that you use on GitHub, just like our card unloader guy, will get you in trouble, right? So in the case of Malware Tech, he had code for hooking that was on, like process hooking on GitHub, and that was actually ultimately what was a large piece of evidence that tied him to the Kronos baking malware. And that's what ended up with getting him pleading guilty for that type of stuff. So it's one of those things where you can actually, when you can get to these like levels of knowledge about the actor, there's ways to get, like I'll talk about them, there's ways to go the last mile with law enforcement help, and they will find those guys. And that's how we've been so successful over the past, where you see all these BEC actors and these botnet creators that are getting put in jail, especially the bulletproof hosting, where they just raided Cyberbunker in Germany. Like it's usually the work of private industry infusing and injecting information into the law enforcement community for them to go and get the information that they need to actually put these guys behind bars. So this is a really fun part of the presentation, because I'm going to talk about some gray area aggressive hunting techniques. Like these are the ways that you could sort of get to real identity and information on some of these guys and track them a little bit more directly. Now, this is your mileage may vary. All the stuff that I'm going to talk about is technically legal. The EFF actually says that it's defensible, so you can actually do this stuff. And there's companies that build their models off of these things, like canary tokens and whatnot. But it is also, on that gray area because of the different types of interaction that you're having with those actors. So the first one I'm going to talk about is going to be beacons. So beacons are really fun because it's basically like when you inject beacons or honey tokens, you inject in the data captured by the malware. So the point behind it is that, like, when we're talking about that's card unloader. Yeah, it looks like card unloader C2 traffic. Well, that OS and then the base 64, if you go back, you'll say, okay, OS is operating system, right? And then base 64, you go through like CyberChef or something like that, and you decode it, and it's like, oh, Windows 10. So it looks like, if you know how panels work, is that they're putting all that stuff into a database, and then they track all of that stuff. So I'm guessing in the back end, there's going to be some sort of spreadsheet thing on a website that shows like, all right, you have 10 Windows 10 computers that are compromised, and they can use that. Well, what if you don't put Windows 10? Like what if the malware, when it queries what type of system it's on, it doesn't give back Windows 10, it gives back something like image, phone home, tracker.pmg. Well, beacons work this way. When you put something in that's going to get rendered by a web page, it will actually, if you have a resource that's external, it's going to go out to phonehome.com and try to get the tracker.png image. Well, when you own the web server, you get logs of who's trying to get different types of resources from a web server. So when you see someone trying to get tracker.png, then you know that that browser is reaching out, which is the admin panel of the actor reaching out to your web resources to get that image. And theoretically, you're going to get information about that actor. And this is what a lot of marketing tools do. When you get those emails where they're like, oh, we know you didn't open up that email, it's because they have a 1x1 pixel that basically tells them when you went and recovered that 1x1 pixel, and that tells them that you opened up the email. Because if you open up your email and it renders, that's where they get our emails get this much read rate. So taking it from marketing, which is always on the cutting edge of how to get data from people, as we know from Cambridge Analytica, they've had this technique for a while now, and now malware researchers are using it. And there's actually even a company that was created by one of my friends that does this. So we can go through the whole life cycle of how we can use a beacon to identify this stuff through this really canonical example here. And so we started, and I actually did this like last night. So this is like hot off the press type stuff here. So we see a blog post or a Twitter post from someone saying, oh, I just found a LockieBot sample. Here's the C2 information. I'm like, okay, cool. Well, who is that guy, right? So you go into that platform, and that platform, what it does is it automatically injects honey tokens into the C2 beacons of the malware. And it automatically does these. It just tries to get as many malware samples as possible. And then when it says, like, what is your processor type? It's like, it's this tracker. And then it's like, what is your OS type? It's this tracker. Like, it just goes and just changes all that information on the fly so that it's always just injecting tokens. And then what you get from that is that you're able to identify the adversary IP when they go and check their panel. So you could see that this guy actually checked the panel on the 6th and the 8th of this month, which is pretty hot off the press. You can even get their user agent information. There's other information that's available. And then if we go back and think about what that panel infrastructure was back when we were looking at the open directories, admin a PHP. So it looks like, and then equals report. Like that's interesting stuff. So they're looking at the report. That data was rendered. It pulled the pixel. And you're able to get that information because they were opening up and looking at how many people they hacked that day. So that's really the big part there. And then you could go down and you could do like the who's information, so you see it from the UK. Now there are some limitations to this, and there's legalities. So according to the EFF, this is legal because you're not directly executing code on the attacker infrastructure. Actually, what you're doing is saying, you're just basically lying about what your system is, and then they're actually, on their own behalf, connecting out and getting the resources from your web server. So it's calling back versus you logging into their database and taking all their victim information, which most likely would be illegal unless you had law enforcement support. There are limitations to this as well. Hackers use VPNs, Tor, and jump boxes, and that can make attribution a little bit more difficult. But we also have something called persistent cookies. So persistent cookies are just like when we talk about cookies on web browsing. You know how Facebook knows when you've logged back in and that you are you? It's a session cookie. That browser has a token that it has, and it says, this is who I was, and then it gives that back, and then it's like, okay, you can stay on and be logged in, so you don't have to re-log in on that stuff. Well, there are persistent cookies that are basically used to store our preferences, settings, information for all of your future visits. And when people go and try to get a web resource from you, you can tell their browser to create a persistent cookie and record that information. The thing about that and why that's really good is because when they go on a VPN, they're probably using the same browser. So that persistent cookie is going to be the same. When they go through Tor, they're going to be, they might be using their Tor browser, so that will be different. But if they go through like their jump box and they're doing like a SSH proxy or something like that, that's going to be the same browser. That's going to be the same persistent cookie. So you can actually track the actor beyond the IP limitations using that type of information. So if you can find that data and when we can get to the point where we're actually able to get like the hard IP of those actors, how do we actually do anything from that? Like where does this go, right? Well, the last part was law enforcement notification. One of the big things that you need to understand when you're doing law enforcement notification is that you have to have, especially for the FBI or something along those lines, they have to identify a victim within their jurisdiction before they can act on that, and they can persecute that for the most part. So that's going to be one of the big things. And then also, to do that, usually what they'll do is they'll try to find victimizing information. So typically companies aren't going to go like, oh, I'm going to give all this information to the FBI. Usually the FBI is like, oh, we saw this happen and we saw your information on the attacker infrastructure. And how do they do that? Well, they seize the infrastructure and they acquire evidence. That's a leverage that law enforcement has that private sector usually doesn't. We usually will use sinkholes that can sort of give you that information, but they can actually go to the ISPs with warrants and stuff like that, and they can actually capture that data and look at that data and log into those databases. So when you get those database credentials, if you say like, if you make a blog post that's like, oh, I tracked this criminal actor, we have a ton of information on them, this is how their malware works, oh, and we also have their database information, I promise you that the FBI will email your company's contact page and say, we need to talk to this person, because it's happened a couple times. And that's typically how they'll work, is if they can see that there's an easy way to, they can subpoena the ISP and say, who had this IP at this time? And that's the way to get to that person's house. And they can also find the victims by looking at the infrastructure and saying, okay, this is the data that was stolen, and so these are where the victims are, and that's another way to do it. And then after they can identify those, and they do that, they have a couple devices. So the indictment's a big one if they're outside of the United States, and it's not like an immediate issue. They're usually going to just indict. They also do the knock and talks. So sometimes some of those actors are young, and they're kids doing sometimes kids things, but because internet is so prolific, their kid things are very prolific. So therefore, they'll knock and talk. So they'll basically go to the house. They'll say, this is illegal, and this is going to end you in jail. We promise you that. And then sometimes those kids turn around. And luckily, I think one of the guys that we showed here, he's done that because I've seen him in some security conferences and whatnot. So that's good there. And then also like raids. They will catch you if you are making enough money and you're very successful. You won't be for long. And when you go on vacation, they will know, and they'll raid and make sure that they get all your information, all your data from your operations, and they'll try to capture you in a way that you can't destroy any of that stuff. And they typically use that when there's large enough need for that activity to stop. We've seen that with Game Over Zeus, the black hole exploit kit. That guy was on vacation or something like that, and he got raided, and we've seen it with a lot of other stuff from there too. The last one is really, other than that, you can do disruption operations as well. So if you know that there's infrastructure on like GoDaddy, you can go out to GoDaddy and say, hey, can you shut this down so that they can stop attacking us? Or you can go ahead and talk to email providers or anything along those lines. ISPs, if their ASNs are in a certain ISP like AT&T, if you tell them that they're one of their provided entities is doing something bad, they'll usually shut it down right away. And so that's another way that you can do it without having to have the law enforcement injection from there. So there's other options other than getting people's doors knocked down, but there are ends to means for a lot of this activity, and I've seen the breadth of them, and it really is just an ongoing fight, a cat and mouse game, and there's always going to be new actors and new mitigation levels. So on that note, I think I'm right on time. That is the end of my presentation. Are there any questions? Yep. Oh yeah. So basically, the question is, for students that want to get involved in malware research, what are the safe ways to sort of start looking at some of these things like downloading malware, looking at that stuff? Well, you guys are in the perfect time. There is so many resources out there, from YouTube to all these other stuff. I would say doing these things in a VM is going to be really great. So making sure that you sort of make sure that your VM is, locked down. And there's a lot of YouTube channels on how to make a malware analysis VM. A lot of times, that's really all you need. All the other information is out there, right? So like a lot of these tools, and I will probably provide my slides out to Stroshine to produce somewhere or make available. If you look up all these tools, they're all free. I mean, VirusTotal Intelligence is the only thing that I think is up there that you have to pay for directly, but even as a student, you can get access to it, and also the free version takes you a long way. So finding that new malware, URL House will get you there. There's a lot of different options there. So the information is out there. This is actually some of the best time to do that, and I've seen like people who have blogs that don't have formal malware analysis training. They don't have a company behind them with a lot of budget to do this stuff, and they found interesting things just by knowing the different stuff to look at. So taking some of these techniques and sort of looking across, you will find stuff. And you'll find stuff that companies haven't even found yet because there's just a lot out there, right?
So I know you're at the Clear conference yesterday as well.
Yep.
So with Malbeacon, do you foresee more products like that coming up should that legislation pass?
I know there's more products like that coming up. A lot of my friends have been starting companies that are based off along those lines because attribution is one of those things where it doesn't help the company, but for law enforcement, we need to start making sure that there are consequences for people to do certain things. There are pathways to learn how to deal with malware and learn how to work with malware without making malware nowadays. And you can also make malware in a legitimate standpoint from red teams and exploit development. So like there is no reason to be there's great ways to become a hacker without being a cyber criminal, and those are two different terms. And so like right now, like back in the day, fair enough, there weren't a lot of opportunities for doing exploit development, but like now you guys have classes on that. And so that's really, I think, why a lot of these are coming into play is because we need to start putting people behind bars for these stuff. And BC actors are making billions of dollars a year by exploiting people, and we need to make sure that there's consequences for those to deter people from thinking that's a viable option for their futures.
And last question from me. Have you played with that JA3 tool at all? And if you have, what's the expense for calculating some of those signatures?
It's free. Actually, you can actually get that information. Oh,
So, I mean, the runtime cost of how much it takes to generate that fingerprint.
Oh, it's based off of the PCAPs. So it's actually, it's on the fly. Dakota, which is a free IDS tool. Some of the people are associated with that in the room here. They actually calculate that automatically on the fly. So you can actually run a PCAP through a Dakota box, and then it just spits out the JA3 hash, and you could use that to track malware. And that's typically how you would do it, is you'd have it in your sandbox behind Dakota, and you'd get that value from there.
All right, thanks.
Yep. So which book would you like? Because you won a prize.
As TJ was saying, yeah, Suricata will generate it. In order to generate intelligence around it, you would have like a rule set. So if you look at abuse.ch, they have a lot of JA3 rules for like Emotet, but then you would put the rules into the IDS generates the JA3, compares it to the rules, and you get some intelligence out of it.
That's pretty new. I mean, over the last year, it's been pretty prevalent, and that's a great research area because attribution is big.
And it's also really good for tracking when you're dealing with TLS, because then the conversation's encrypted, so you can't see FRE.php or something, but now you maybe have a JA3 that you've associated with a campaign or an actor that gives you some intelligence where maybe you didn't have it before. Other questions? I think there's still one more. Oh, you go. Okay. I thought you were just waving really enthusiastically.
All right, so the beacons thing, how long do you think before the Wild West is over with the beacons? Or also, to what extent can they cross, to other nation states before like it's like a big problem internationally?
The malicious beacons, I mean, there's a lot of deception companies, which is sort of the impetus of this technology that are out there. So now companies are just deploying these as default. So I think what you're saying is, do malware actors are going to get wise to it? Yeah, they've already started getting wise to it. They've been getting a little bit better. I know from my friend that runs the Malbeacon company, like he actually notices that some malware families actually protect actively against it, which means that they have to up their security level. But making that change and making it a little bit harder for the actors to operate is really what it's all about. Is, you know, putting people to against the consequences that they should be facing for doing these type of activities, and then making it harder for them is the only way to sort of make our society better, especially like the cyber world. If it's always a free-for-all and people could just get away with everything, then obviously we know we know that it would just be more prevalent. So that's really what it is. There's definitely ways to block that, but when you have opportunities, especially like in malware research,